So this will be part 2 from the previous video I did in the playlist. So now moving on to a muscle contraction overview. So when a performer sees a stimulus with their receptors, so this could be your eyes, those stimulus could be a football, they think about the response they wish to bring about. So the brain sends an electrical impulse from your brain through your spine into a motor neuron, where it then crosses the neuromuscular junction to make the muscle contract to react to the stimulus using the sliding filament theory. So using the example of a football, when a performer sees the football, their message is sent down through their body and it brings about the response of kicking the ball at goal, per se, for a shot. So it goes from receptor down into a motor neuron and brings about a response. Okay, so now a more in-depth look at the neuromuscular junction. So after an impulse travels across a motor neuron by saltatory conduction, it comes to the end of the neuron, which is called a motor unit. And this, as I've talked about before in the other video, that different muscle contractions with different muscle fibers require different types of motor units. So within each motor unit, there are multiple synapses. Synapses are gaps between the end of a neuron and the muscle it's going to. So once the impulse reaches the synapse, vesicles release a neurotransmitter called ACH across this gap. This allows the impulse to cross the gap and reach the muscle for contraction. This jump of the synapse from the neuron to the muscle is known as the neuromuscular junction, as it's going from a neuron to a muscle, so neuromuscular. So now I mentioned this before, the sliding filament theory. This is how muscles actually contract within the fibers. So after the impulse jumps the synapse and makes it to the actual muscle, it travels through T tubules in the muscle until it reaches the sarcoplasmic reticulum. This is a calcium store. So once the impulse reaches here, calcium ions are released across the myofibril and over the sarcomeres that line the myofibril. So these things here, this is known as a sarcomere, and these line all across the myofibril. So calcium ions are released over the sarcomeres. So when relaxed, the actin filaments within a sarcomere are blocked by troponin. This stops myosin, when it's given ATP, from binding to it. However, when calcium ions are released over the sarcomere, the calcium ions bind to troponin, which changes the shape of the troponin and tropomyosin, and therefore this opens up the site, the actin binding site, which now means that myosin, when given ATP, can attach to it. This is shown in this little diagram down here where it binds to it. So once it binds, the myosin pulls the actin filament, which is then connected to the Z discs. So when the myosin pulls the actin filaments, the actin filaments move closer, as well as the Z lines move closer. And then when myosin is given more ATP, it releases and then binds onto another actin binding site, which pulls it across even more. And this keeps going until the impulse stops. So now when the impulse stops, calcium ions are no longer released from the sarcoplasmic reticulum. So troponin and tropomyosin change back to their original shape, which blocks the actin binding site. So therefore myosin is no longer able to bind to it and pull it across, so the contraction stops. And what I just sort of talked about there is shown in these diagrams, where is the relaxed and contracted, so it pulls it across. And this diagram here shows how the myosin attaches to the actin filament. Okay, lastly I'm going to talk about different types of muscle contractions. So there are different types of muscle contractions, and this is important in sport as different movements require specific and different muscle contractions. For example, a marathon runner's muscles will contract differently to that of a 100-meter sprinter. This is sort of what we talked about before with the different fibers. or a rugby player's muscles will contract differently to a ballerina's. Also, different movements, depending on their direction and also their weight balance, require different contractions. So there are three main types of contractions. There's concentric contraction. This is when the force going upwards must be more than the weight going downwards, and therefore causing an upwards motion. This also causes the muscle to shorten. So concentric contraction means the muscle shortens and with an upwards motion. So this is sort of shown in this diagram here in the bicep curl. This is the upwards motion of a bicep curl is concentric contraction. Eccentric contraction. This is when the force acting upwards is less than the force acting downwards, so it causes a downward motion, and the muscle contracting lengthens. So here in the bicep curl, in the downwards action when coming down off the curl, is an eccentric contraction, and what a lot of people mistake is that the muscles, it's not the antagonistic pair, it's the same muscle doing the same contraction. It's just lengthening and shortening and the different types of contractions. And so the last type is isometric contraction. This is when the two forces acting upwards and downwards match and they are therefore balanced. So there is no change in length, but the muscle is still contracting, holding the weight up. So like we can see here, when you're just holding the weight out sort of in a right angle position, not really shown in a right angle here, but your muscle is not gaining any length or decreasing any length, but it is still contracting to keep the weight up, and it's balanced in the force going upwards and downwards.